Hello children, welcome back to my channel. I am now dealing with the circles of ninth class, Theorem 12.3. The perpendicular from the center of the circle to the chord bisects the chord. What does it mean? It means, see, this is the circle and this is center of the circle, and AB is the chord and OD is perpendicular to AB. We need to prove that AD is equal to DB. So, what is given to us? A circle with center O, and AB is a chord. What is RTP? We need to prove that AB is a chord. Also, we have got OD is perpendicular to AB. This is also given. OD is perpendicular to AB. What is RTP? We have to prove that AD is equal to D. Now, there is a construction here, children. What is this construction? You have to join OA and OB. Join OA and OB. Now, let us go to the proof. Now, here is children, you have got two triangles. One is triangle AOD and another one is triangle BOD. So, let us talk about those two triangles. In triangle AOD and triangle BOD. In these triangles, OA is equal to OB because they are radius. See, from the center to vertex, to circumference. If you draw a line segment, definitely it is a radius. So OA is OB. OA is equal to OB because they are radii. So we can say that they are equal. And OD is common for these two triangles. So OD is equal to OD. It is common. For both, it is common. And at the same time, they said OD is perpendicular to AB. So angle ODB is equal to angle ODA. So triangle AOD we are talking about first here. So angle ODA is equal to angle ODB, that is 90 degrees. They said no perpendicular. Therefore, triangle AOD is congruent to triangle BOD basing on RHS property. See, right angle, hypotenuse, side. RHS property, we could say that two triangles are congruent. When these two triangles are congruent, every side is equal, no? So therefore, AD is equal to DB. Hence, proved. This is what they asked you to prove. The perpendicular drawn from the center of a circle to a chord bisects the chord. That means divides the chord into two equal parts. Okay, please note it down, children. Now, example 1, children. Construct a circumcircle of triangle ABC, where AB is 5 centimeters, angle B is 75 degrees, BC is 7 centimeters. So already you have done it in your previous class. Once again, an explanation for it. See, children, what I am doing, the measurements are different. You have to do it by using your scale and compass. Mainly with the scale, I may not get it properly, but explanation will give you how you have to construct. If you follow exactly what I am saying, definitely you can construct it. Use your instruction, that is compass box, and then do it. Okay, how it has to be done step by step I'll teach. Let us see. First, what you have to do, AB. First AB base, AB 5 centimeters they said. So let me draw AB. This is 5 centimeters suppose. A and B do it with 5 centimeters. Then angle B 75 degrees by using the protractor, keeping the protractor the 0 here, 75 degrees. So from here this is 70, 75. Okay. You have to draw BX ray. This is BX making 75 degrees. So angle B 75. BC is 7.5 centimeters. So 7.5 centimeters actually, let me take this approximate measure I am taking, children. 7.5, suppose you see. You have to draw an arc. This is C. This point is considered as C. Now you have to join A and C. Now after joining A and C, what we need to do is to draw a circumcircle. Circumcircle means around this. What you need to do is you have to draw the perpendicular bisectors of AB. Perpendicular bisector means A as center, more than half of AB as radius. You have to draw one arc on one side and another arc on another side. Similarly, without disturbing it, B as a center, you have to draw B as a center. You must draw another arc. Of course, if this arc is not intersecting, you have to extend the previous arc. See, children, my board is very slippery. So, like this, if you draw, you can join these 2 points. So this is the perpendicular bisector of AB. Now we need to do the perpendicular bisector of BC. So more than half of BC as radius. One arc this side and one arc this side. Again, with the same measure, C as a center, cut this arc. My construction box is not, it is slippery, children, here. So, I may not get properly, but method you see. These two, this is perpendicular bisector of BC, this line. This point is considered as G. The point where these perpendicular bisectors are meeting is called G. So G as a center, C as radius or A or B as you wish. As radius, if you draw a circle, the circle passes like this. You are getting a circumcircle. So let us see what are the steps for it. The steps are: first one, construct triangle ABC with the given measures. You need not write how the triangle is constructed, children. It is not required. How the triangle is constructed is not required. That is previous class portion. You have to construct the circumcircle. That construction is important. Next, draw. Let me name this P and Q. Draw PQ, the perpendicular bisector of AB. So the perpendicular bisector of AB, I named it as PQ. And third one, draw, we call it as MN. Draw MN, the perpendicular bisector of BC. Now, fourth point, PQ intersects MN at G. See point, this is G. Fifth point, G as a center, GA, anything you can write, GA as a radius, draw a circle. Sixth point, the circle passes through B and C. Seventh point, the circle so formed is a circumcircle. This is what your construction is, children. Of course, I'm saying no, my construction cannot be very perfect because the instrument will be slippery. This is whiteboard. So even if I use, it is slippery, so the rays, the arcs are not properly occurring. But I feel that what I am doing, with the help of that, you will understand how you have to keep your instrument and use it to do this construction. Please do it, children. Now, example to children. Figure is this. In this O is the center of the circle. Find the length of CD. If AB is 5 centimeters, and of course angle they have given. So now we will take, I'll write it here. In triangle AOB and triangle COD, two triangles. OA is equal to OC. They are radii. OA and OC are radii, so they are equal. OB is equal to OD. These are also because they are radii. OB and OD. And angle AOB is equal to angle COD. They have given both of them as 55 degrees. Therefore, triangle AOB is congruent to triangle COD basing on side angle side property. When they are congruent, AB will be equal to CD. Therefore, what is CD? CD is also equal to 5 centimeters. This is the answer, children. Very simple one. Please note it down. Now, example 3. In the adjacent figure, there are two concentric circles. What is the meaning of concentric circles, children? Concentric circles means two circles with the same radius. Means by using compass, one circle you will draw with the same center, another circle upon it. If you draw with more radius, then we are getting two concentric circles like this. Now, there are two concentric circles with center O. Chord AD. See, AD is the chord of the bigger circle. A chord AD of the bigger circle intersects the smaller circle at B and C. Show that AB is equal to CD. This is what you need to prove. What is given? Two concentric circles with center O. AD is the chord of larger circle and AD intersects the smaller circle at B and C. This is given to us. Now you need to prove what is RTP. We need to prove that AB is equal to CD. Let us go to the proof, children, directly. Proof is AD is the chord of bigger circle and OE is drawn perpendicular to AD. This is given to us. OE is drawn perpendicular to CD. Therefore, you can say that AE is equal to ED basing on the theorem which we have learned. Similarly, we can say BE is equal to EC. Same way, because for the small circle, these two, this is the BC is the chord and this is perpendicular. So, therefore, what is AE? Let us talk about AB. They are asking AB. What is AB, children? AB is nothing but AE minus BE. AE minus BE. What is AE? AE is nothing but ED. ED minus EC. ED minus EC. What is ED minus EC? That is ED minus EC is from ED if you minus EC, this is CD. Therefore, AB is equal to CD. Hence, proved. In this way, you can prove. Because in the theorem, just earlier case, in the earlier before construction, I have taught you the theorem, children. The perpendicular drawn to the chord bisects the chord. Basing on that theorem only we are doing. OE is perpendicular to AD. So AE will be equal to ED. Basing on the theorem. Similarly, this is smaller circle. So OE is perpendicular to BC. So BE is equal to EC. So AB you want AE minus BE. AE is nothing but ED. BE is nothing but EC. So we are getting AB is equal to C. I hope I am clear, children. Please note it down. With this, I am going to end my topic. In the next class, we will see the next part.